You curl an API. You get this. Now what? JSON, JavaScript Object Notation, is the universal structured data format. Objects with key value pairs, arrays of items, strings, numbers, booleans, and null. Real JSON is nested. Objects inside arrays inside objects, sometimes 5 levels deep. Your eyes are not a parser. Scrolling and squinting is not a workflow. Enter JQ, a lightweight, pipeable command line JSON processor built for slicing and transforming JSON. Pipe anything into JQ and you get colorized, indented output that a human can actually read. The most basic filter is the dot. Type dot field, and JQ hands you that top-level key. Type .a.b to drill into nested objects or .a0.b to step through an array index. Arrays iterate with dot. Combine it with a pipe. Dot field. And JQ walks every element, plucking the field you want from each one. The dot items. Shorthand does the same in one step. Notice those escape strings in the output, the literal \n characters and surrounding quotes? That's valid JSON, but it's ugly. Add the R flag and JQ strips the quotes and unescapes the values, giving you clean raw text. This is the Unix philosophy in action. Small tools, sharp tools connected by pipes. Curl fetches, JQ slices, and whatever comes next, grep, awk zargs, a shell loop consumes the clean output. JSON becomes just another stream of text you control. We start with a clean terminal session to demonstrate what an API response looks like on the wire before any parsing is applied. Each step runs one command at a time, so the output is unambiguous. The goal is to build intuition for raw HTTP responses before introducing tooling like JQ. Before we fetch anything, we check whether JQ is installed on this system. The operator runs the fallback only if the first command fails, so a missing JQ prints no JQ instead of an error. This is a quick, idiomatic availability probe. Now we hit the GitHub REST API for the Linux repository. The S flag silences curl's progress meter, and head, C200 truncates the response to the first 200 bytes, so we can see the JSON opening cleanly. This is exactly how you eyeball a response before deciding how to parse it. Increasing the window to 500 bytes reveals more of the structure. Nested objects like owner, visibility flags, and human-readable URLs. You can start to recognize the schema just by reading the raw text. JSON is self-describing once you slow down and look. To know the true size of the payload, we pipe the full response into WC with the C flag, which counts bytes. This number tells you exactly how much data the server sent. Useful for logging, rate limit planning, and sanity checks. The pipe pattern is identical to the previous commands, just swapped at the end. Not every GitHub API endpoint returns JSON. The /zen endpoint returns a short, randomly chosen piece of programming wisdom as plain text. This is a great reminder that APIs are not guaranteed to return structured data. Always inspect before you assume. Finally, we verify connectivity and HTTP status without printing the body. The o/dev/null flag discards the response, and the W format string prints just the status code. A single line of output, clean, scriptable, and the standard way to health check any endpoint. Raw JSON from the GitHub API arrives as an unreadable wall of brackets, quotes, and commas. A chaos monster blocking your pipeline. Enter JQ, a robed wizard who slices JSON like a master chef, pulling exactly what you ask for with a single dot and a field name. First slice. That full underscore name returns a clean string, Torvald/Linux, the repository's full identity pulled from the JSON tangle. Second slice. That owner.login dives into nested objects. Owner is a subobject, login is its field, showing how JQ walks the JSON tree. Third slice. Stargazers_count pulls a raw number untouched, 198,537, because JQ preserves data types exactly as they live in the JSON. Fourth slice. Topics iterates an array, printing every topic string on its own line, kernel Linux operating system, each flowing out one after another. Fifth slice. Description // no description demonstrates the alternative operator. If the field exists, use it. If missing, fall back to a safe default. Now the crucial flag. Without R, JQ prints Linux kernel source tree, wrapped in JSON quotes. With JQ, R you get Linux kernel source tree, raw, clean, ready for shell variables, grep, awk, and zargs. This is the power of composability. Curl into JQ. R then redirect, pipe, or store. The JSON wall becomes a clean field flowing anywhere your shell takes it. In this demonstration, we'll work with JSON data directly in the Linux terminal using curl and JQ. We'll fetch live API responses, measure their sizes, and extract structured fields. Each scene shows the exact command and its realistic output. Before anything else, we confirm JQ is installed. The which command locates the binary, and the operator runs the fallback echo only if which fails. Seeing a path like /usr/bin/jq means the tool is ready to use. Now we fetch the Linux kernel repository metadata from the GitHub API. The S flag silences curl's progress meter, and head C200 keeps only the first 200 bytes, so we can preview the JSON structure without dumping the entire response. Increasing head to C500 reveals more of the payload, including nested fields like owner, HTML_URL, and the start of description. This is a useful technique when you want to inspect an unfamiliar API before parsing it fully. To handle the full payload reliably, we need to know its total size. Piping the entire curl response into WC, C returns the response size in bytes, here around 2.6 kilobytes, which is small enough for JQ to process instantly. The GitHub/send endpoint returns a random short saying each call, demonstrating that not every API speaks JSON. Plain text responses are common, and JQ won't help here, but they pair nicely with curl for quick smoke tests. Finally, we verify the HTTP status code without saving the body. The o/dev/null discards the response, and the W format string prints just the numeric code. A clean 200 confirms the endpoint is reachable and responding normally.